So I previously made a video on logarithms, and I promised to make a video on natural logarithms. So here it is. What exactly are natural logarithms? Well, logarithms can have any base, but natural logarithms can only have base e, and e is approximately 2.718. The notation for natural logarithms are ln. So say you have log base e of x, this is written as ln of x. There are also a few things you need to know. ln of 1 is equal to 0, ln of e is equal to 1, and you also need to know the properties. So the product property says ln x plus ln y is equal to ln xy. The quotient property says ln x minus ln y is equal to ln x over y. And last but not least, the product property says ln x to the power y is equal to y times ln x. So let's solve some problems. Log base e of e. Well, if you watched my logarithms video, this was the last question. So how can we write log base e of e in natural logarithm notation? Well, we know log base e is just ln, and log base e of e would just be ln e. So this means that this is equal to 1. Alright, so then we have e to the power ln 5. Well, ln is just log base e. So we can rewrite this ln as log base e of 5. Well, the e's just cancel out. This just becomes 5. Now we have log base e of 1. Well, this is just ln of 1. And we know that that is 0. Now we have ln e to the power e. Well, ln e to the power e, using the power property, this is just e times ln e. So this is e times 1, so it's just 1. Alright, and now we have ln 1/3 plus ln 3. Well, using our product property, ln 1/3 plus ln 3 is just ln 1/3 times 3. ln 1/3 plus ln 3 is just ln 1/3 times 3. So ln 1. Well, what's ln 1? ln 1 is equal to 0. ln 4e minus ln 4. Well, we can use our quotient property. ln 4e minus ln 4 is equal to ln 4e over 4, which is just ln e. And this is equal to 1. ln to the power ln times ln of e to the power 12 minus 4. Alright, well, we can use our product property, and we get 12 times ln e minus 4. Well, ln e is just 1, so this becomes 12 minus 4, and this is equal to 8. Alright, now let's move on to our word problem. Bob has $400 in his bank. The bank annually compounds at an interest rate of 10%. Bob wants $1,000 in his bank account so he can buy a new computer. how long will he need to wait until he has enough money to buy the computer? Well, we can use a formula. A, the money he wants, $1,000, is equal to P, the initial money he has, times E, which is approximately 2.718, to the power R, the rate, times T, the time it takes. Well, we know A is equal to 1,000. We know P is equal to 400. We know E is approximately 2.718. We know R is 10%, or 0.1. And T we do not know. So let's just plug all these values in. 1,000 is equal to 400 E to the power 0.1 T. Well, we can divide 400 on both sides. We get 10 over 4, or 5 over 2, is equal to E to the power 0.1 T. Now we can just take the natural log on both sides. ln 5 halves is equal to ln e to the power 0.1 t. Well, the right side looks familiar. It's just the power property. So this becomes ln 5 halves is equal to 0.1 t times ln e. Well, ln e is just 1. So ln 5 halves is equal to 0.1 t. Now we can divide by 0.1 on both sides. We just get 10 times ln 5 halves is equal to t. Now we can see t is equal to approximately 8, meaning Bob will have to wait 8 years until he can get his computer, which is kind of sad.